Welcome to our exploration of the top 10 Python concepts every programmer should master. Python is a high-level, interpreted programming language known for its readability and versatility. It has gained immense popularity in various domains such as web development, data analysis, artificial intelligence, and scientific computing. The simplicity of Python's syntax allows developers to express concepts in fewer lines of code compared to other programming languages, making it an excellent choice for both beginners and seasoned programmers. In this video, we will delve into essential Python concepts that will enhance your coding skills and deepen your understanding of the language's capabilities. Whether you are just starting your programming journey or looking to solidify your existing knowledge, mastering these concepts will provide a strong foundation for your future projects. Let's get started. In Python, understanding data types is fundamental to effective programming. The primary data types include integers, floats, strings, and booleans. Integers are whole numbers, such as 1, 2, or floats represent decimal numbers like 3.14, or strings are sequences of characters enclosed in quotes, which can be anything from hello world to Python 101. Lastly, booleans represent truth values, true or false. Knowing how to manipulate these data types is crucial, as they form the basis for data operations in your programs. For instance, you can perform arithmetic operations on integers and floats, concatenate strings, and evaluate conditions using booleans. Understanding these data types will help you choose the right type for your variables and optimize your code for performance and clarity. Control structures are essential for directing the flow of your program. In Python, the most common control structures are conditional statements and loops. Conditional statements such as if, elif, and else allow you to execute different blocks of code based on certain conditions. For example, you might check if a user's input meets a specific criterion before proceeding. Loops, on the other hand, enable you to repeat actions. The for loop is particularly useful for iterating over sequences, such as lists or strings, while the while loop continues executing as long as a specified condition remains true. Understanding these structures allows you to create dynamic and responsive programs that can handle various scenarios, making your code more versatile and efficient. Functions are a cornerstone of Python programming, promoting code reusability and organization. A function is a block of code designed to perform a specific task, which can be defined using the def keyword followed by the function name and parameters. For instance, a simple function could calculate the square of a number. Once defined, you can call this function multiple times throughout your code, reducing redundancy and improving clarity. Functions can also accept parameters, allowing you to pass data into them and customize their behavior. Understanding how to define, call, and pass parameters to functions is crucial for writing clean, maintainable code and is a skill that every programmer should master. Object-Oriented Programming, or OOP, is a programming paradigm that uses objects to represent data and methods. In Python, everything is an object, which allows for encapsulation, inheritance, and polymorphism. Classes are the blueprint for creating objects, defining attributes and methods that the objects will have. For example, you can create a car class with attributes like color and model, and methods like drive and stop. Inheritance allows one class to inherit the properties and methods of another, promoting code reuse. Polymorphism enables methods to be used interchangeably across different classes. Understanding OOP principles is vital for developing complex applications and allows for better organization and scalability of your code. In programming, errors are inevitable, and handling them gracefully is crucial for a robust application. Python provides a mechanism for error handling through exception handling using try and except blocks. When you anticipate that a certain block of code might raise an error, you can place it within a try block. If an error occurs, Python will skip the rest of the try block and execute the code in the except block instead. This allows you to manage errors without crashing your program. For instance, when dealing with file operations, you can catch exceptions related to file not found or permission errors, providing users with helpful feedback instead of a program crash. Mastering exception handling is essential for writing resilient code that can handle unexpected situations. Organizing your code is essential for maintaining and scaling projects, and Python's modules and packages facilitate this organization. A module is simply a Python file containing definitions and statements, which can be imported into other Python scripts. This allows you to break down your code into manageable pieces. For example, you might have a module for database operations and another for user interface logic. Packages are collections of related modules grouped together in a directory, allowing for hierarchical organization. Utilizing modules and packages not only enhances code organization, but also promotes reusability, as you can easily share and incorporate existing code into new projects. Understanding how to create and use modules and packages will significantly improve your coding efficiency. File handling is a crucial aspect of programming that allows you to read from and write to files on your system. In Python, you can open a file using the open function, specifying the file name and mode, such as R for reading or W for writing. Once opened, you can read the contents of a file line by line or all at once, and write data back to files. For instance, you might read a CSV file to process data for analysis or write logs to track application performance. Proper file handling also involves closing files after operations to free up system resources. Understanding file handling is essential for data persistence and is a skill that will enhance your ability to build applications that interact with external data sources. List comprehensions are a powerful feature in Python that allows for concise and efficient code when creating lists. Instead of using traditional loops to generate lists, you can use a single line of code to achieve the same result. For example, if you want to create a list of squares from 0 to 9, you can use a list comprehension like this: x *** 2 for x in range 10. This not only makes your code cleaner, but also improves performance. List comprehensions can also include conditions, allowing you to filter items easily. For instance, x for x in range 10, if x%2 == 0, generates a list of even numbers. Mastering list comprehensions will help you write more Pythonic and efficient code. Managing project dependencies is crucial for any developer, and Python's virtual environments provide a solution for isolating project-specific packages. A virtual environment allows you to create a self-contained directory that contains all the necessary libraries and dependencies for a project without affecting the global Python installation. This is particularly useful when working on multiple projects with different requirements. By using tools like venv or virtualenv, you can create, activate, and manage these environments easily. This practice not only prevents version conflicts, but also simplifies the deployment of applications. Understanding how to set up and use virtual environments is essential for maintaining clean and manageable code bases.